In today's lecture, we are going to cover section 2.5 from the textbook. And in this lecture, we are going to learn how to solve some kind of differential equations using an appropriate substitution. Let me first remind you what we studied before. The kinds of the differential equation which we studied. First kind was the separable differential equation. Separable differential equation. And if you remember, let me write the form of separable differential equation. It is y prime equal g of x times h of y. And also I can write this equation as dy over hy equal gx times dx. So the separable differential equation, which we studied in lecture number 2, is very important, and to solve it, only you need to write all y together in the left-hand side, maybe, and all x together in the right-hand side. Then integrate both sides of your equation. This is the first kind of the differential equation which we studied in lecture number 2. Now, in lecture number 3, we studied the first order linear differential equation. And the standard form, which you need to write your equation to solve it as a first order linear equation, it is the following: y prime plus bx times y equal f of x. And to solve this equation, I remember we studied 2 steps. The first step is to find the mu x, and I think all of you remember the rule of mu x. And second step is to write the equation mu times y equal the integral of mu times f dx. By solving this equation, you will find y, which is the solution of your differential equation. Then we moved to the kind which we call it, so number 3, third kind, which we studied the exact differential equation. And I remember the form of the exact equation, it is the following: mxy, or the function mxy times dx, plus function times dy. So it is plus nxy times dy equals 0. So this form for the exact differential equation. And also I have here 5 steps to solve the exact differential equation. If you remember, first step is to check the exactness by the following condition: partial n by partial y must be equal to partial n by partial x. If this condition is satisfied, then you can say it is exact equation and go to the second step, such that you will find your f, which satisfy partial f by partial x equal to m. Then you will integrate this equation. So f, it will be the integral of m plus g of y, if you remember. Then to find gy, you will write the partial f by partial y equal n. Then you will get the value of the function g, plug in value of the function g in the step 3, so you will get your fxy equals c, the solution of the exact equation. Okay, those the materials we studied in the previous lectures with the initial value problem also. If you remember, initial value problem, that means you have differential equation with the specific initial conditions, and depending on this initial conditions, I'm going to find the value of the constant in my solution. Now, in today's lecture, we are going to study three kind of differential equations, and this kinds can be solved using an appropriate substitution. First kind, if my differential equation in this form, so I have differential equation y prime, it is f of y over x. So let me explain here more. If my function f of x, it is x squared plus 1 or plus x plus 1. Okay. Now, what about of f of apple? So my function f, it is x squared plus x plus 1. Can anyone give me the answer of f of apple? What do you think of f of apple? Before that, let me ask you about f of 3. Could you please help me how to find f of 3 depending on my f? F of 3 is well. Can anyone help? How to find f of 3?
Substitute.
Substitute. Yes, speak. So what should I write?
3 squared plus
3
3
squared plus 3
plus
plus 1.
1.
You are right. What about What about of f of apple? So my 3 now, it is apple. Yes, Omar.
Yes, we substitute also.
Yes, speak. So what should I write now?
Apple squared.
So apple squared plus
Apple plus 1.
1 plus 1. So also now, if I ask you to give me f of y over x, so it will be y over x squared plus also y over x plus 1. So now y over x, this one, it is an apple. So in today's lecture, if I have differential equation like this, y prime equal f of y over x, I can solve it using an abbreviated substitution, which I'm going to explain in the coming lecture, in the coming slides. Also, second differential equation, which I can solve it if my y prime is the function f of linear expression between x and y. So notice it's only x and only y. No product between x and y. No y squared, no y cubed. Okay? So I can solve also this one. So now what I want to tell you also, if I have one of those two kinds, I will use an appropriate substitution to convert my equation from this form, one of them, into a separable. Also, the third kind, which I'm going to solve today, look to this kind. It's very similar to the linear equation. Look here, it's very similar to the linear. But unfortunately, in my right-hand side, I have also y to the power n. So the left-hand side is similar to the linear equation. But in the right-hand side, I multiplied my f with a function, with a y to the power n. This equation, we call it Bernoulli equation. Bernoulli equation. And to solve it also, I have specific substitution. I will use it to convert it into linear equation. So all the differential equation which I'm going to study today can be converted into separable or first order linear equation, depending on an appropriate substitution. Let me start by the first kind, which is y prime equal f of y over x. Before that, let me ask some students to help me. Maybe I need Farida to help me. Can you hear me, Farida?
Yes, Doc.
Yes, Farida. So now I'm going to discuss with you how to solve this equation. Is it separable? Is it first order linear? Or is it exact? What do you think about linearity? Is it linear?
No,
No.
because of the x squared and y squared.
Yes, so it isn't linear. Can we separate the variables such that all x together and all y together? Can we do that?
Still no. I
Also
don't
no.
think so.
Now, let us check if it is exact. Okay? What should I do to check if it is exact or no?
To check if it's exact, we separate them and we get the m and n.
Yes, so what should I
Then-
write now? Yes,
Okay,
help me.
so it's going to be xy dy.
So cross product, great.
Yes.
xy dy, okay,
Equals x squared plus y squared dx.
great, yes, dx. Then I
Okay,
will
so
move, yes,
the dx to the other side.
yes.
So it's going to be xy dy plus.
xy dy plus or minus?
We could make it plus and change the signs inside the
Okay,
bracket.
okay,
Negative x squared minus y squared.
great. Dx equals 0. Where is your m? And
Our
n?
m is negative x squared minus y squared.
Oh, great. It's the coefficient of dx,
dx.
and this is my n. Now let me check the condition. Do you remember the condition? It is?
It was partial m over partial x.
No, partial m
Partial
by
y.
partial y.
Okay.
And partial n by partial x.
Or
You will differentiate the function with respect to the other variable. So here the
okay.
m is multiplied by x. I will differentiate it with respect to y. So partial this function with respect to y, it will be
It will be negative 2y.
negative 2y, great. And the partial of this n with respect to x, it will
It's going
be
to be y.
y.
So it's
Those
not
aren't
exact.
equal, isn't not exact equation, not exact.
Yes.
So I can't solve this equation depending on the previous 3 lectures.
Yes.
So the new idea, which I need you to understand, is try to change the form of the right-hand side. So thank you very much, Farida. And anyone of you now, could you please help me to change the form of the right-hand side? Also, Farida, if you have any answer, you can answer. Anyone of you. I need to change the form of my right-hand side.
You can write it as x over y.
X, so you will separate your fraction into 2 fractions. So
Yes,
it is x squared over xy, continue please, plus
y squared over xy.
Yes, great. So look, Omar suggests to write my fraction as a summation between 2 fractions because I have a plus up. But if the plus down, you can do that. You can't do that. Now I'm going to cancel something. So here, this is y prime equal squared with x. So it is x over y plus, and here the squared with y. So it is y over x. Notice now, this function, this is my f. I can consider it as f of y over x. Am I right? Now let me ask you about this f. If I need to find f of an apple, so it will be like what? I need f of apple. Don't forget that y over x is a flip of x over y. Yes, speak.
Apple plus apple power negative 1.
Apple plus 1 over apple. Yes, great. Very nice. Or I can say it is apple plus apple to the negative 1. Great. So also here, I can say now, let me choose y over x to be u. So my y prime, it is, yes, what should I write? If you choose this substitution, so this term will be what?
Y power negative 1 plus y.
Yes, great. It is 1 over u plus u. Am I right? This y over x, it is u. And x over y, it will be 1 over u. Okay? So now I found one substitution which will help me, and it's a rule. If your equation y prime equal a function of y over x, so to solve this equation, you should use this substitution. Okay? Is it clear now how to check or how to write my equation in this formula? Only you need to write your right-hand side in another way. Okay? Let me write everything in details in the coming slide. So now, after finding that this equation isn't separable, isn't first order linear, isn't exact, I will try to write my right-hand side in another form such that now I have y prime equal x squared. Here I'm going to write everything in details. Divided xy plus y squared divided xy. That will give me y prime equal x divided y plus y divided x. And I'm going to use the following substitution: y over x equal u. That will give me the y equal x times u. What do you think about this? Is it right? Only cross product. From this, I should find y prime. Professor, why do you need to find y prime? Because my equation, this equation, has y prime. Okay, so I need to, so the idea of the substitution is to convert your unknown function from y into u. So I will convert my unknown function from y into u. So you need y prime. You need to find y primes in terms of u prime. Now let me ask Abdullah Shihabuddin. Abdullah. Can you hear me, Abdullah? Yes, Abdullah. Now you have this expression or this substitution. From this, I need you to find y prime. So we are going to differentiate both sides. What about the differentiation of x times u? You have a product. You remember the rule of the differentiation of a product between two functions?
Yes. U plus x.
So the derivative of the first one, which let me write in details. The derivative of the first one, which is 1 times u. Great. Plus what? Repeat.
1 times x.
Could you please explain the second one, which you told me now from where? So this one for me, look, Abdullah, this one, it's the derivative of x.
The x, yes.
Yeah. So the rule said derivative of the first, which is 1, times the second, the same, it's u. Plus what? Derivative of the second. Yes, you are right. Derivative of the second. What about of the derivative of u? Is it 1? Now we will try to find the differentiation with respect to x. So the derivative of u, it is u prime. U dash as y prime, okay, times x. Great, Abdullah. Yes. So now, thank you, Abdullah. Now I'm going to substitute this u prime in equation star. So equation star will give me, instead of y prime, you found u plus u prime x. Any question about this differentiation? Because I go to solve the equation. Any question about this differentiation? Did you get the idea, all of you, why the derivative of u, it is u prime, not 1? Because u is my new function instead of y. So let us continue. Equal. Instead of x over y, you asked me to write 1 over u plus, instead of y over x, as you explained here, it is u. So don't forget, from this equation, you can say 1 over u, it is x over y. Okay? Now I'm going to simplify this equation. Only, yes, I can move this u here. So it is u prime x equal 1 over u plus u minus u. Yes, great. Now I can cancel u with u. So I have u prime x equal 1 over u. Don't forget that always when you use similar to this substitution, you will get a new differential equation with a new unknown function u without any y. If you have y here, so you did something wrong. Now, always, when I use this substitution, I will convert my equation into separable one. So I need to separate the variables here, and let me choose Mira. Now, I explained that always when you will use this substitution, you will get separable equation. Could you please help Mira how to separate the variables here?
I can move all y together, u together, and x together.
Yes, that's what I need to do.
I will multiply by u,
so
and divide by x.
Multiply by u and divide by x. You are right. What about of u prime? What do you think about u prime? Is it u prime? It is du over dx. So let me write u prime first of all. It is du over dx, okay, times x equal 1 over u. And now you asked me to divide by x and multiply by u and multiply by dx. Am I right?
Yes.
You should also separate the dx. So now what should I write?
So it's dx x
dxx, you are right. So x dx, you are right. Okay.
and u du
UD.
equal.
I think there is something wrong. What do you think? So could you please repeat? What should I write now?
Okay. When we divide by x, it will be. I can make it step by step. Du
Yes.
over dx equal
Yes.
x over u, and then
X over u. Look, you need the dx and the du to be up. Okay. So you have to leave du as it is. So I'm going to write du here. Okay. And equal. You multiplied by dx to make dx up. So dx here. Am I right? Now, you need to divide by x. So here, divided x. And here, you will cancel this x. Also, you need to multiply by u. So this u will be up. Am I right now, Mira? What do you
You're
think?
right.
Yeah. So now, what should I do now? After separating all u together and all x together, what should I do?
Now I will integrate both sides.
Yes. So here integral and here integral. Yes, help me, please. What about the integral of u du?
It will be u squared over 2.
Great. Equal. About integral of dx over x, it is?
Ln x.
Ln absolute
C.
value of x plus c. Great. Now you found the solution, but unfortunately with u. And for me, I don't know anything about u. You try to use u. Go back to the original of u. It is y over x. So instead of u squared, I'm going to write y over x all squared divided to equal ln of absolute value of x plus c. This is my solution. Actually, if you stopped here in the exam, you will lose 1 mark because I don't know you. You used you. Okay? Yes, thank you, Mayor. Any question about this problem? No questions? So let me go to the second one now. Here the steps also, but usually I prefer to write everything in details by hand. And here the rule. So the rule, if you have differential equation, so general case number 1, if you have the derivative equal f of y over x, use this substitution. Then find y, then differentiate both sides and plug in your equation. Okay. Now the same substitution, which is u equal y over x, can be used. So the same substitution, u equal y over x, can be used to solve this equation in this formula. But it isn't exact. But this equation, to be solved using this substitution, must satisfy specific condition. So now you learned that this substitution can be used to solve this equation, which is y prime equal f of y over x. Also, the same substitution can be used to solve the equation of this form when the equation satisfies specific condition. This condition, we call it homogeneous function of degree alpha. So I have this equation, and this equation, it isn't exact, isn't linear, isn't separable, but this equation satisfies specific condition. We call this condition homogeneous coefficients of degree alpha. What I mean by this condition? So now my coefficients are m and n. I need to check if both of them are homogeneous of degree alpha. Now, Professor, what do you mean that a function is homogeneous of degree alpha? Let me explain that in details. We call the function f homogeneous of degree alpha if this function satisfies this condition. F of tx comma ty equal t alpha times my function. No, doctor, it isn't clear. Give us an example. Let me check if this function, so I have this function, and I need to check if this function homogeneous of any degree. He wrote here degree 3. So let us check if this function is homogeneous of degree 3 or no. How to do that? I have to take f tx ty. So I'm going to choose f of tx ty. Professor, what do you mean by tx ty? So I'm going to plug in instead of every x in my function, the amount t times x. And instead of each y, I'm going to plug in t times y. So equal. Here, my function. Instead of x, I have tx. So it will be tx cubed. Plus, instead of y, I have ty. All power 3. This will be, now tx to the power 3, it will be t to the power 3 x to the power 3. Plus, also, ty to the power 3, it will be t to the power 3 y to the power 3. Now, I can take common factor t to the power 3. So it will be t to the power 3 x to the power 3 plus y to the power 3. Notice now this bracket, it is my function. So the answer, it will be t cubed times f of x and y. So now ftx ty is given to be t cubed times the same function. So I can say now my function f, this one, is homogeneous of degree 3, because I have t to the power 3. Let me give you another example. My function, so I'm going to clean those now, and my function f of x and y, it is x plus y squared, y cubed, no problem, y cubed or y squared. Let me choose another example. And I need to check if this function homogeneous or not. What should I do? I'm going to write f of tx ty. So I'm going to plug in instead, sorry, I'm going to substitute instead of every x by tx and every y by ty. So this x, it will be tx plus this y, it will be ty, all squared, equal tx plus t squared y squared. Now, can I take all the t as a common factor? Can I take all the t as a common factor?
No.
What do you think? No. So this function isn't homogeneous. This function isn't homogeneous. So if you can take all the t common factor, you will say that this function is homogeneous. If you can't, so the function isn't homogeneous. Now my aim, if I have equation like this, and it isn't separable, it isn't exact, it isn't linear, I can check if m and n, both of them homogeneous of the same degree. So maybe you can take t squared common factor or t common factor from both of them, or t to the power 3. So both of them are homogeneous of the same degree. So to solve this equation, you can use this substitution. Okay, so this substitution can be used to solve two kinds. First one, y prime equal f of y over x, or the differential equation can be written in the differential form such that the coefficients m and n are homogeneous of the same degree. Let me solve one example similar to this equation. So I have this equation, I wrote the equation here. And let us together try to do it. First of all, let me ask Muhammad al-Tuhami. Muhammad here. Yes. What do you think, Muhammad, about this equation? Is it linear or no? Linear or no? What do you think?
It's not linear in y, not linear in x.
Yeah. Can you separate the variables?
We have x, y, and we have summation, and we have subtraction, so no.
Yeah. Let us check if it is exact or no. This is my m, and this is my n with the minus. And to check if it is exact or no, I'm going to find partial n by partial y and partial n by partial x. Yes,
Partial
help me now.
Partial n partial y is equal to 2y
2y
plus x
plus x, great. And partial n by partial x,
is equal to negative 2x.
negative 2x. Those aren't equal, not exact. Not exact. How to solve it? So it isn't at all from any one of the kinds which we studied before. So for me, also now I studied a new kind of differential equation. Maybe, so let me write first of all that my mxy, it is y squared plus xy, and plus xy, I'm sorry, and my nxy, it is negative x squared. Now I'm going to check if this equation homogeneous of specific degree or no. To do that, I need to check if my m and n are homogeneous of the same degree. To do that, I'm going to take mtx and ty. So help me, Muhammad, now to find mtx, ty. What should I write?
Okay, we will say ty all squared
Ty all squared, great,
plus tx
times
ty times ty.
I need to simplify this. So ty all squared, it will be t squared, y squared. Am I right? Plus. What about of this product?
T squared xy.
T squared xy. Can I take a common factor, something?
Yes, t squared.
So t squared, here I have y squared plus xy. So equal, I have the same function now. X squared times plus xy, it's my function. So it's t squared mxy. So now the m is homogeneous of degree 2. If my n also homogeneous of the same degree, so my differential equation is homogeneous of degree 2, and I can solve it using this substitution. So let me now also find mtx ty equal. Yes,
negative t squared x squared.
Negative t squared x squared. I can write this as t squared bracket negative x squared. So it is t squared nxy, great, nxy. So also now this of degree 2 and this of degree 2. So I can say my equation is homogeneous of degree 2 or of 2 degree. So to solve it, it's a rule now. To solve it, if both of m and m are homogeneous, to solve it, use the substitution. Let u equal y over x. Thank you very much, Mohammed. So now, what I'm going to do, I'm going to do to do the cross product. So the y, it is x times u. Am I right here? Any question about this step, about this substitution? Now, I need help. What should I do now?
Get y dash.
Get y dash. If I find y dash, where should I plug in it? Or where should I substitute it? Unfortunately, my equation has no y prime or y dash. So if I found here y dash, where should I plug in? If no y prime here, or can I solve this issue? So what should I do now?
Maybe we can rearrange the equation.
How? Yes, you are right, but how?
So we will first get the negative x squared and dy to the other side.
Great, then?
I'll divide by dx, so it's going to be
Great. 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 This is a great method. But sometimes the students prefer not to change the form of the equation. So I'm going to continue solving this problem using another instead of the differentiation here, I'm going to find the differential for both sides. Instead of differentiation of the both side, I'm going to differential both of side. Why I'm going to do that? Because here I have dy and I have dx. But you are free. You can change the form of your equation by dividing both sides by dx, and you will get y prime from here, and you substitute out. Okay? For me, to use another technique, I'm going to differentiate to find the differential for both sides. So the differential of y, it is dy, equal the differential of any product. It's very similar to the derivative of any product. Is given to be the differential of first, it is dx, times second, plus the differential of second, which is du, times the first function, which is x. What do you think about this? Do you remember it? It's the rule for the differential of this. If you don't need to deal with this, you can divide with dx here by dx. So you have y prime, and you can find the derivative of both sides here, and you can continue solving the problem. Okay? Now for me, I need to let the students understand also this idea. So I'm trying to solve it using this differential. So let me plug in my equation. In equation star, this is my equation star in differential equation. Instead of y, don't forget always when you try to use this substitution, you must write the new equation in terms of only u with no y. So instead of y prime, I'm going to write x squared u squared plus x times, instead of y, I have xu times dx minus x squared. Instead of dy, I have those u dx plus x du equals 0. You have any question here? Is it clear?
Doctor,
Now, yes.
I'm sorry, I'm confused. I'm confused. What step did we do after we made sure that the differential equation is homogeneous? I don't know how to say.
Yes. So after you check if the equation is homogeneous or no, you have to use this substitution. You have to write in your cheat sheet that if the equation homogeneous, I'm going to use this substitution. Okay, it's a rule. Then I will find y. How to find y? Cross the product. Here the denominator 1, so it will be x times u. Okay?
Okay.
Now, yes.
Should m and n should be the same degree, homogeneous of the same degree?
Yes. So here t squared and here t squared. If one of them t cubed and the second t squared, no, it isn't homogeneous, and you can't solve it using this substitution. We have to find a new method. Okay? Now, after writing the y like this, usually we find the derivative of both sides. So here, y prime. But now in my equation, no y prime. There is dy. So your colleague suggested to divide both sides by dx. And at that time, you will get y prime. Great. This is a new, this is a beautiful method. But for me, because I have here dy and dx, and the difference between dy and y prime, it is differential, not derivative. So I'm going to find the differential for this equation. The differential for this equation, differential of y, it is dy. Differential of any product is similar to the derivative. So I need to find differential of first, which is dx, times second, plus differential of second, which is du, times the first, which is x. Okay? After finding this, I'm going to plug in my differential equation. Instead of y squared, you have xu squared. I wrote. Instead of x, I leave x, but instead of y, I wrote xu. Minus x squared. Instead of dy, I wrote this expression here. Is it clear?
Yes, sir. Thank you.
So, wait. So now what I'm going to do, look here, x squared, and also those are x squared. So I'm going to take them as a common factor. So x squared, bracket, u squared, plus u dx, minus here also x squared, u dx, plus x du, x du, equal 0. I can divide both sides by x squared. So I have now, and I'm going to multiply this inside. No, I think, what should I? Should I multiply those inside? Or what do you think? I think it isn't necessary because here, yes, you can do that if you need, you can, but I'm not going to do. I'm not going to do. Why? Because it's a common factor. So it isn't necessary to do it because I need to take a common factor now. So here I have u squared plus u dx. Now I'm going to multiply this. No need to multiply because I cancel out x squared and x squared. I'm sorry. So it is negative u dx, negative x du equals 0. Now, I don't need to write the steps by my own. I need one to help. What should I do now? What should I do? It's only mathematics. Yes?
We should multiply the x by u and then cancel it with
Great,
u
great,
dx.
great. So it will be u squared dx plus u dx and negative u dx and negative x du equals 0. Now you are right. I'm going to cancel those two terms out. So my equation now as the following. I'm going to clean the yellow. I don't need the yellow here. So I have u squared dx minus x du equals 0. How to solve this equation? How to solve this equation? Who will help? Don't forget always when you use this substitution, you will get separable equation. Can we separate those? What do you think? What should I do?
We can take the u squared dx to the other side.
Yes, so it is u squared dx equal x du. Yes, then
we would divide by x and u squared.
divide by x and u squared. So I will have now dx divided x equal du over u squared. Great, it's separable equation now. What should I do? I'm going to take the integral here and the integral here. Continue, please. So the answer will be the integral of dx over x, it is ln absolute value of x, equal integral of du over u squared, it is negative 1 over u. Am I right? Plus c. Now go back to your u. I don't know anything about this u. So ln x equal negative 1 over y over x plus c. This is your solution. You can write this in up to be negative x over y plus c if you need. What do you think about the problem? Is it clear now? If you use this substitution, so we'll get separable equation, okay? And you can solve it easily. Let me go to the second kind of differential equation, which I need a new substitution, not similar to those, okay? Now, actually, I have those two problems. This one included in your worksheet. This one isn't included, I think. Could you please try to do this one and send me your solution on WhatsApp? And by the way, I'm going to solve it, but in the coming lecture, not today. Number 9. So please try to do this and send me your steps to check the difficulties which you find, and I will explain it in the coming lectures. Number 9. So this one is a new cheat sheet, so maybe we'll discuss it later at 1 o'clock. Now, if I have this differential equation, and together, actually this equation isn't linear at all in x and in y, because the cosine has x and y. And this equation isn't separable because I can't separate the x and y inside the cosine. Also, it isn't exact at all. It isn't exact at all. Also, it isn't homogeneous of any degree, because if you write tx and ty, you can't take t common factor outside of the cosine. And I can't write it as y over x because I have cosine and here 5. You can't. So if you take common factor x, so it will be 5 over x, not y over x. So I can't solve it using any one of the previous method. Now, the new method, if you have differential equation of the form y prime equal f of ax plus by plus c. Now, where is my f in the differential equation here? Where is your f?
Sine function.
It's cosine. It's cosine. To solve it, the appropriate substitution is to choose this, all those to be u. So to solve this equation now, I'm going to use all those to be u. It's a new idea, a new substitution which you need to learn. Let us together do this equation in details. So here, the equation, it was y prime equal cosine x minus y plus 5. Because it isn't exact, it isn't linear, it isn't separable, it isn't homogeneous, I'm going to solve it as u equal x minus y plus 5. Notice here, those, all of them are linear. It isn't x squared, it isn't y cubed. No product between x and y. To solve it, you need to find y. Okay, so I'm going to move y here and u here. So my y equal x minus u plus 5. Always, when you try to use any substitution, that means you will convert your unknown function from y into u. Now I'm going to differentiate both sides, but let me ask you, Yusuf, could you please help to find the derivative of both sides? Doctor, why do you need to find the derivative, not the differential now? Because my equation has a prime. So derivative of y, it is y prime. What about the right-hand side, Yusuf?
1 minus u over du over dx.
Or u
dash
prime, you are right.
Right.
Great. And what about 5?
0.
0. Great. Now go to your equation. Instead of y prime, you told me it is 1 minus u prime equal cosine. Instead of all those are only u. Am I right? What should I do now? Always, after using any substitution, like this or the previous one, you will get a separable equation. How to separate the variables now? What do you think about this equation?
So it will be 1 minus cosine u equal du over dx.
Great. So du over dx, which is u prime, equal
1 minus cosine u.
1 minus, I'm so sorry, 1 minus cosine u. You are right.
Then it will be 1 over 1 minus cosine u du equal dx.
Great. So du over 1 minus cosine u, you divided both sides and multiply by dx, so equal dx. Okay. So what should I do now?
Integrate both sides.
Integrate both sides. Integral here and integral here. Now let us, I'm going to find one of those integrals, and you, all of you, should find the second one and send me on WhatsApp. For me, I'm going to find this integral. It is x plus c. And you need to find this integral and send it to me on WhatsApp as a private message. All of you. I know sometimes the integrals will take more time to find, but I need you to practice how to define those integrals. And it isn't important for me because I know some students will write this integral in the cheat sheet, okay? And some of them will find this integral on Google, okay? But I need you to practice, okay? So all of you must find this integral and send me your integral on WhatsApp.
Doctor, I
After
have a question.
finding, yes, ask.
Uh, about the substitution, so we can substitute by anything, or should be only any specific solution for the substitution one?
To find this integral or to solve this differential equation?
No, like we said u equal x minus y plus 5. So
Yes. Can
can
I
be-
use another substitution? No, because I choose the inside function to be u. You can't say that u equal y over x. No, at that time, no.
so it
For
depends
this
on the
equation.
function.
Depend on the form of my differential equation or the right-hand side of my differential equation. You are right.
Okay, thank you.
Great. Okay, so did you get the idea? What I need you to do is only to integrate this du over 1 minus cosine u. Maybe you need to use conjugate, or maybe you need to use the double angle rules to find this integral. Okay.
Doctor,
Yes.
we'll get برضو يعني after integrating both sides we'll get the solution على طول صح؟
You will get a solution in terms of u.
And then I will
Something with
substitute.
u. Go back to your u. Go
Yeah.
back to your u. Okay.
Thank you.
Yeah. Now let me go also to solve another problem of this. So here the rule that if the differential equation of this form, I'm going to use this substitution. Let me solve the following example. Also number 27 in your cheat sheet. What do you think? Can you do 25 or by your own? So please, no, I'm going to do it now with you. So the differential equation, it is y prime equal tan squared of x plus y. Am I right? This is my equation now. It is. Yes, tan squared x plus y. This equation isn't linear, isn't exact, isn't separable, isn't homogeneous, but it is function of linear expression between x and y. So to solve it, I'm going to use the following substitution. Let u equal x plus y. That will give me my y. It is u minus x. Differentiate both sides. So y prime equal u prime minus 1. In my differential equation, I have u prime minus 1 equal tan squared of u. Don't forget now, this equation must be separable. I will move number 1. So u squared equal 1 plus tan squared of u. This equation must be separable. So u prime, it is du over dx equal 1 plus tan squared of u. And now I'm going to separate the variables. So I will get du over 1 plus tan squared u equal dx. So here I divide by 1 plus tan squared and multiplied by dx. What should I do? Integral here and here.
Doctor,
Yes.
can we use trigonometric identities like 1
Yes,
plus
you are
tan?
right. You are right. I should use I should use it. Yes. So 1 plus tan squared, it is what? Do you remember?
6 square.
6 squared. You are right. So who is speaking now? What's your name?
Abdullah.
Abdullah. Yes. So it is 6 squared. 6 squared of u. You are right. So instead of this integral, let me write, Abdullah suggests to use this instead of this. I'm going to write 6 squared. And by the way, if you didn't use it here, you should use it here. You can't find the integral without using this. So here it is 6 squared of u, and here 6 squared of u. Now, how to find this integral? What do you think? For me, here x plus c. And your homework to do this, or do you want me to help? How to do this integral? What do you think? So here,
Is it equal to
Yes.
cosine square?
You are right. Who is speaking also now?
مروان يا دكتور.
Yes, Marwani, great. So it is du over 1 over cosine squared u. Because the 6 square, it is 1 over cosine squared. So this can be written as integral of cosine squared of u du. And how to find this integral? How to find integral of cosine squared?
Using the identity.
double angle.
Double angle, you are right. So it is integral of, do you remember the rule of cosine squared? It is what? It is half 1 plus cosine 2u du. So this, it will be half u plus, what about of the integral of cosine 2u? It is what? Integral of cosine 2u, it is half?
u over 2.
Half, yes, half sine 2u. Okay? All those must be equal to x plus c. Now go back to your u. Go back to your u. It is x plus y. Okay, so I think the students must do some revision about the integration and the double angle rules, or some identities of trigonometric functions. Okay? Do you have any question? Let me go to the last kind of the substitution, but please write your names. Write your names, please, in chat. And now I'm going to introduce the third kind, which we call it Bernoulli. Who is Bernoulli? This man is a very great mathematician and who first solved this equation. So the first one who solved this equation was Bernoulli. And Bernoulli suggests a specific substitution to solve similar kind of this equation. Notice here, the left-hand side, it's linear, but unfortunately now my y with power n here. So this equation isn't linear at all, but the left-hand side is similar to linear. So we call it Bernoulli. And we are going to use this substitution, which Bernoulli who first suggests. This substitution, your u will be y to the power 1 minus n. From where I'll write this n from here. And by using this substitution, I will convert this equation into linear one. And you will solve the linear equation as we know. Okay? Let me explain in details in the following example. So I have this equation. Let us discuss together. Is it linear? No. Is it separable? No. Is it exact? Actually, I checked, and you have the idea now. You will find similar to this equation in your exam. You have to check if it is exact or no. By cross product, find mn, partial m by partial y, partial ln by partial x aren't equal, so this equation isn't exact. Can I separate the variables? No. Can I write it as y over x or x over y? Also, I can't, because here you have y over x, but unfortunately here you have x to the power 3. Can I check if it is homogeneous or no? Yes, I checked and it isn't homogeneous. So what should I do? I'm going to convert or to change the form of the right-hand side. So let me write everything in details here. Look what I'm going to do. So I checked if this equation one of the previous forms, but unfortunately it isn't at all. So what I'm going to do, only I'm going to change the form of the right hand side. Don't forget that I checked if it's separable, if it's homogeneous, if it's exact, and it isn't any one of the previous forms. For me, I'm going to write in the formula y prime equal y over x plus x cubed y cubed divided x. To simplify this equation, I'm going to write it y prime equal 1 over xy plus x squared y cubed. Yeah, what should I do now? Actually, I know it's Bernoulli, so I'm going to move this term. So here, y prime minus 1 over xy equal x squared y to the power 3. Now, this equation is similar to Bernoulli, which is y prime plus px y equal f of x times y to the power n. So it is Bernoulli or Bernoulli equation. Okay? Now, to solve it, Bernoulli suggests to use the following substitution. Let u equal y to the power 1 minus n. So u equal y to the power 1 minus. Where is your n? Where is my n? From where I can find n? Can anyone speak? What is it? What is my n?
Is it 3?
3. This is my n. Comparing between this equation and the Bernoulli form. So 3. So equal y to the negative 2. So you found u equal y to the negative 2. You should find only y. So from this, I can write u equal 1 over u squared. Am I right here? And also from this, you can write, yes, I need to find y. So what should I do? I need to find y. Can anyone help? Here I have y squared. One student will ask, Professor, why do you need y? Why do you need y? Because I have y prime here in my equation. I have y prime. So I need to find y, then differentiate to find the derivative of y. Can anyone help how to find y? What do you
Y
think?
equals square root of 1 over u.
Yes, you are right. So let me do it in details. First of all, I'm going to take the square root for both sides. Okay? So I'm going to take square root for both sides. So square root of u equal 1 over y. Now flip both sides. That means 1 over root u equal y. Am I right? So the y, it is u to the negative half. Am I right here? Take the root of u up, and don't forget the root is to the power half. Take it up to be negative. Now differentiate both sides. So y prime, how to differentiate u to the negative half? It is negative half times u to the negative half minus 1 times u prime. Am I right? So the y prime, it is now negative half u to the negative 3 over 2, which is negative half and negative 1. So negative 3 halves times u prime. Now I'm going to plug in my equation. So where is my equation? This is my equation here. This is my equation. Where let me plug in this. Maybe it's better. Let me use blue now. I'm going to plug in here. I'm going to plug in here. Okay. So this equation, it will be, instead of y prime, you found negative half u to the negative 3 over 2 times u prime minus 1 over x. Instead of y, I'm going to plug in here. Instead of y, you have u to the negative half equal x squared times your here y to the power 3. Y to the power 3. So I'm going to write this to the power 3. So it is u to the negative half all to the power 3. Let me simplify this equation. Yeah, what should I do now? Yeah, first of all, let me write this in another formula. So I have negative half u to the negative 3 over 2 u prime, negative 1 over x u to the negative half equal all of them x squared u. Now this u, it will be what? This u, it will be what? U to the power what? You remember?
U to the power negative 3 over 2.
Yes, you are right. U to the power negative 3 over 2. Only multiply between the two powers. Now, to simplify this equation, I'm going, just a minute, I'm sorry. I'm going to divide, so here divide, by those. Or look what I'm going to do. I'm going to divide by u to the negative 3 over 2, and I'm going to multiply by negative 2. I need to simplify my writing, only my equation. So you will multiply by negative 2. If you multiply by negative 2, so you will cancel this. And you divide by u to the negative 3 over 2, you will cancel this. So you have only u prime. If you multiply by negative 2, so it will be plus 2. 1 over x, u to the negative half, and you divided it by u to the negative 3 over 2. Am I right here? Equal. You multiplied by negative 2, so negative 2x squared. And you divide, so here negative 3 over 2 and u to the negative 3 over 2. Let me simplify this also. I'm going to cancel out this with this because the same, and I'm going to take this up. So u prime plus 2 over x. And now if I take this up, so it will be what? Can anyone help? Negative 3 over 2, it will be what?
U power 3 over 2.
Yes, so it is plus. And here negative half.
If we take it downwards, it's going to be y power half.
No, leave it up. Leave it up. I need all of them up.
Oh, sorry. And 3 over 2 minus half.
So 3 over 2 minus half. 3 halves minus 1 half.
It's
It
1?
will be, yes, you are right. 1 half, so sorry, it's 2 halves, so it's 1 times u equal. And I cancel out this with this, so I have negative 2x squared. What do you think about this equation? What do you think about this equation?
Separable.
Separable? Who said separable?
Mira.
Mira. No, I think it isn't separable. I'm going to clean the yellow here up. Do you need the yellow? So check last equation. It is what?
Linear?
Linear. It is first order linear equation. And you have also to write in your cheat sheet that if I have separable equation and I solved it using this substitution, I will get a new differential equation in terms of u instead of y, and this equation, it is first order linear differential equation. Now I'm going to solve this first order linear equation depending on a specific steps which we studied, if you remember. Let me ask Fatima. Fatima Hamad? Fatima here?
Yes.
Yes, Fatima. Do you remember the steps for solving first order linear equation? First step, it is, yeah. By the way, you can write everything on your cheat sheet and you can answer my question during the lecture depending on your cheat sheet or from your notebook as you need. Do you remember the steps? First of all, let me write here my P. This is my P. And this is my F. With the minus. With the minus. This is my F. So do you remember first step, Fatima? It's to find what?
mu of x?
Yes, to find mu of x. Do you remember the rule of mu of x?
It's
It is
e power integration of p of x dx.
Great, dx. Where is your b?
It's 2 over x.
2 over x. And this integral is what?
As the ln e power ln
Yes,
2 ln x.
2 ln x. How to simplify it?
It will be x squared.
X squared, great, because you will take the 2 up and cancel. Yes, this is x squared. This is the first step. Second step is to, yes, do you remember? Yes.
Yeah, mu x times y.
Times y equal, but now it isn't y, it is u. Am I right? Now
Yeah.
I convert my y into u. So u equal integral of mu times f dx. Am I right? That will
Yes.
give me x squared times u equal integral of x squared. Where is your f?
Negative 2x squared.
Negative 2x squared. You are right. How to find this integral now? Dx.
It will equal negative 2x power 5 over 5.
Yes, so it is x squared u equal the negative 2 outside, and this it will be x to the 4. And the integral of x to the 4, it is what?
X to the 5 over 5.
X to the 5 divided 5 plus c, you are right. Now we didn't finish because you find the solution in terms of u. Go back. Instead of u, you have y to the negative 2. So go back to the u. X squared times, instead of u, you have y to the negative 2 equal negative 2 divided 5 x to the 5 plus c. Thank you, Fatima. This is my solution in terms of y. Is it clear? What do you think about Bernoulli? I think Bernoulli need more time than the other substitution, but also be sure that you will find in exam 1 and maybe in the final exam also one equation as Bernoulli 1. So do you have any question about the steps? Actually, I don't have time to do another example, but I can help during the assembly hour to do worksheet at 1 o'clock. Yes, who need to ask?
Doctor, I'm sorry. I'm confused after we get the, like it seems we always get the step اللي هي آخر step الأبيض دي اللي هي the y dash.
Here you're asking me about this. So always when you use any substitution, you need to find the value of y, as I did here. Then, because in your differential equation you have y prime, so you need to differentiate. So do you want me to explain how I find this differentiation, how I differentiate the function?
No, I understand this, but I'm always confused. يعني بعد كده بنعمل ايه بقى؟ يعني بعد ما نجيب الواي برايم.
Yes. After finding y prime, you have to go back to your equation, to your differential equation, and plug in the y prime in terms of u. I will repeat. After using substitution, you will find y, and you will find y prime. Then both of them substitute in the given differential equation. Instead of every y, write this, and instead of every y prime, write this.
Okay. We just substitute?
Just substitute instead of y something in terms of u, and instead of y prime something in terms of u and u prime. So I will convert my unknown function from y into u.
Okay. Thank you.
Welcome on. Other questions? If no questions, only I need to tell you that we have another problems, but those problems, I can do them now. I will do one problem in our during with the cheat sheet. I can do this now. I will try to find another time to do more problems about this substitution and the Bernoulli equation. Okay. And if no question now, we can meet at 1 o'clock to do some or to do the worksheet, or if you have any question. And I'm going to upload it now. the worksheet. What do you think about the lecture today? So do you have any question?
Doctor, can you upload also the slides so we can refer to the steps?
Yes, actually, look, I'm going to stop the recording. Just 1 minute to tell you what I'm trying to do.